Picking up from the last video to continue our exploration of object-oriented programming, please follow along with this video to make your first class on objects. Over here on the left, we've got a program that makes a car. It's got some data up here. You can think of variables as the car's data, its color, location, and speed. We've got some functions here that show the car or display the car, give it its appearance, and then we've got some actions that it can carry out. It can move forward, it can turn a headlight on and off. So we want to be able to make not just one car, but any number of cars. To do that, we're going to create a class, and the metaphor I'm going to continue to use is that's the car factory. And from that, we're going to make objects, which are the cars themselves. You want to have setup and draw. Programs using classes still have one setup method and one draw method. But we're actually going to use the tab functionality of processing to add our first class. For our purposes in this class, in our class 9th grade programming, you should only be using the tabs to put full and complete classes, as in programming classes, the programming concept of classes, in the tabs. That's the only thing that should go in there. And setup and draw should never go in any tab but this first tab. So I'm going to choose the downward arrow and add a new tab. The name for that tab should be the same exact name as you have for your class. Classes by standard are capitalized. Will they work if they're lowercase? Sure, but think of it like a proper noun. So I'm going to write car for the name of our class and press OK. And here is our car tab. To create a new class, you're going to define it as a class, lowercase c in class, and then, as I said before, capital C in your class name. I'm going to open a curly bracket. Don't put an open close parentheses here. I'm just going to skip a bunch of lines and close my curly bracket for this will close the entire class. And I'll say actually up here, define car as a class. Okay, so the first thing in your car class is, much like the first thing in a program we've written, is to declare some variables. These variables will be local to the class. We'll be able to just use them, initialize them, and use them inside the class. So I'll use color for right now, although for just the start, all of our cars that we make are going to be red. We will get into changing the colors of cars in our classes next week. So I'll just copy this right here. You know what? Now I'll copy, yeah. So I'll say, we'll say color C, int X, int Y. I'm gonna make them floats actually, float X, float Y. Gives us a couple more options, and float S. So these we're declaring class variables. To initialize our class variables, we use a special feature of a class called a constructor. And the way a constructor works is it's the exact same name as the class, capitalized also, put a little space here. Then we're going to put an open close parentheses, another open curly bracket, and a close curly bracket. And again, this is called the constructor. The constructor is like the setup of a class. So it's analogous to the setup. It happens one time when the class creates an object. So one time for each object that the class makes, or one time for each car the car factory makes. And this is where we initialize our variables. So it'd be more analogous if I'd gone through sort of what we'd seen when we were first using the active method of processing, where we'd say color C, and then here C equals, the red color, and so on and so forth, to have X equals location, instead of having separate or all your variables declared and initialized in line. So I'm just going to change that really quickly just so you can see how analogous it is. Sorry, should have considered that ahead of time. It's a little tedious. And also should say speed. Oops. All right, so we're going to do the same thing. Luckily, I've done that right now. And so this again is like the data, the features the car has: its color, its location, its speed. You could also, you could include its size, et cetera, in there. And then what comes next is we're going to make specific methods for the car, and the methods are like actions. They're going to be the things that the car can do that it doesn't have to do all of the time. Certainly a car doesn't need to be moving all the time. Certainly it doesn't need to have its headlights on all the time. And certainly if one car in all the cars I make is moving or does have its headlights on, all of the cars, the rest of the cars don't. Once the car leaves the car factory, it's autonomous. So to define a method, I hope we all remember, we're going to start with void, and then I'm going to come up with my own method name. As I said in the last video, display is kind of the conventional way that we say anything that has to do with appearance. So I'm going to say void display, open and close a curly bracket for the whole method. So this closes display. And this curly bracket, don't forget to close the constructor. And in here, I'm going to just copy and paste everything that has to do with the way the car looks. And then I'm going to make a method called void move. And I'm going to copy and paste the equation that causes our car to move, adding the speed onto the x variable. And then I'll close the move method, and then you also need that entire class is closed. Do not put a closed curly bracket after your definition of class variables. So you just should have two at the end, one closing move, one closing the entire class. Now, this class makes exactly one kind of car at one location with, one speed. 250 feels like it's a really fast speed. Why does that say 2? I must have copied and pasted something incorrectly from before. All right, let's make that 3. Okay, so we're going to make our first car, and then we're going to go back and adjust a couple of things here so we can make cars in a couple of different places. I'm going to click back on the main tab, and to create my first car object. The data type that I'm going to give to my object is the name of the class I just made. So I basically made my own variable. So if I write car, that's saying I want to make an object from this class. In a program you may have many classes. So using that class name says I'm making a new object from that class. And then I'm going to give my car a name. So I guess going back to that slide I had earlier, I'm going to say Mini, maybe that's the car name. And we say equals new car, open, close parentheses. So class name, variable for the specific object I'm making, equals new class name, open, close parentheses, semicolon. So that makes one car object from the class car. So the Mini is the thing that I'm going to use as the variable that is that specific car. If I wanted that, if I play now, nothing is going to happen because I've created the car, but I haven't told it to do anything like show up. So the first thing I want to do is say, tell it to show up. The display method I created, however, is local to this class the same way the variables are local to the class. So again, if I had a lot of classes, I might actually have a lot of display methods, one for each class that I have. So I have to say specifically, what do I want to, which object do I want to display? And the way we do that is something called dot syntax. Dot syntax. And by dot, I really just mean a period. So I'm going to say mini dot display. That says call class mini, or call class display rather, on the object mini. So again, it's saying, okay, a mini is a kind of car. So go into the car class and find that display method. Now if I play it, there's the car. If I wanted to move, I could say mini dot move. And now, because it's called in draw, it's moving all of the time. Like in this last class though, maybe I only wanted to move it sometimes. I'm actually going to say if key equals equals, and then in single quotes M for move or for mini. So now if I press the M key, move. If I press another key, it will stop. And so if I go back to my class, I could add yet another method for the headlights. So it's after I close move, I can say void lights. Oh no. Yeah, lights mean something. Maybe just light. Yeah, okay. And then copy in the functions for the headlights. Again, if I play it at this point, no headlights because I haven't said when I want the headlights to show up. So but maybe I could say have if key L, and then same way using that dot syntax, mini dot light. And if I hit another key, it goes away. So this is call move on mini, call light on mini. Okay, so this is all well and good, but if I were I want to be able to make more than one car. Currently, all of the car objects I make are at the same location. So for right now, let's actually make the cars appear just at a random spot on the y-axis. So let's say random. I don't know, between 100, well, maybe like between 50 and 450. So now, when I play it, my mini will be at a random spot, which will allow me, well, to make and for us to see a second object. So at this point, if you want to try to add a second object independently, you can pause this video, go for it on your own, or you can continue to follow along. All right, so to add a second object, I'm going to use that same class name. It's the car factory. And we'll call this one, I don't know, I'll say Jeep equals new car. And now I've got a second car object. To make it show up, I'm going to do the same thing. Jeep.display. So again, Jeep, it knows, is an instance, we say, of the car class, and it's calling the Jeep's method on the Jeep object. So now if we play it, because I've called move and lights on mini, but only display on Jeep, if I hit M, we know that one's the mini and this one's the Jeep. I could call move on both of them if I wanted to. I could create, maybe the Jeep is moving all the time. So the Jeep is moving, but the mini only moves when you hit M. Or maybe they both move all of the time. I'll put these next to each other. But maybe the Jeep's, got a little more horsepower and it's going to have a faster speed, or maybe it'll have a slower speed. For right now, we're just randomizing them. We're going to make them specific in class next week, but maybe so the speed can go between 1 and 4 for either one of those. And so if I hit L, the mini actually is the faster one in this instance. Now go ahead and add a third instance of the car class. If you've got a little time, the other thing you can do is try, instead of using a color variable, change this to an integer and use the RGB functionality of fill to see if you can get some cars of a different color. Other challenges you could do is add another method. Actually, everybody should try. Everybody should try to add another method of something else your car could do. So your car could, maybe you could add a method that actually makes it speed up by increasing the speed by changing that value of S. Maybe you could add a new method that makes the brake lights go on. You could add a new method if you wanted to. You could add a window into your display method and then have a method here that makes it look like the window is opening. But see if there's something else, another method. So you would, before you close that curly bracket for the whole class, and after you've closed that curly bracket for the light method, add a new method here. And then add a third car object in your main tab. One thing, just to wrap this up, when I save, as you should save, when I save this program, two things. I tried to call this car. I can't call this car because I already have a tab in here called car. So I'm going to say car class, save it. I probably did not save it on the desktop as I had intended. Let's try this for yet a third time. In here, if I open up the car class folder, I now have two different PDE files. As long as they stay in the same folder, it doesn't matter which one I click on, it will open up both tabs together. You can see now actually the main tab, which used to have that generic name it gives a program when it opens, it's now called car class, and my car tab is there. Both of these files need to stay in a folder that has the same exact name as the main tab in order for this to work. So that's again another reason why it will be so important to zip that program. So zip the whole folder to be able to upload that. If I try to unzip this file here right on my desktop, or if I download it somewhere, notice again how it says car class and it is given it a 2 because I already have a car class here. If I try to open my car class here, it's going to give me that error. The file carclass.pde needs to be inside a schedule for the same name car class. If I do that, my tab is not going to come because this car class is not inside, this car file is not inside that car class folder because it's had to give it another one. So if you end up in that situation, it's probably because you've tried to save two different folders in the same place and they can't have the same name. So if you're downloading something and you already have an unzipped file there, just toss it in the trash. And then if you unzip it, you'll get your correct car class there. So just a little bit of file management on the end of this video, and I will see everybody next week.